Can cos pi by 7 be rational? I'm Abhinav, welcome back, and let us find out. So at the first glance, there is absolutely no reason to believe it should be irrational. In fact, today we will prove it without using calculators, decimal approximations, or advanced number theory. We will force cos pi by 7 to satisfy a cubic equation and then destroy every possible rational value. So let us go ahead. So we have to check whether cos pi by 7 is rational or not. In fact, we have to prove that it is irrational. So let us see how that can be done. Let us consider alpha is equals to pi upon 7, this particular angle. Now you can write 7 alpha is equals to pi. Now the next step is to split 7 alpha into 3 alpha and 4 alpha. So whenever I see these kind of things, splitting 7 alpha into 3 alpha and 4 alpha, so these things are not intuitive, all right? So this is the most important skill that you need to crack JEE. So whenever there is sine square theta plus cos square theta, whenever you see it, every student who has prepared for JEE will replace it with 1. But whenever you see a 1, if you are able to replace that 1 with sine square theta plus cos square theta and eventually solve a problem, that is what makes you succeed in these examinations. So we have done the splitting, and now let us take 4 alpha to the other side. So let us apply sine on both sides. So sine of 3 alpha is equals to sine of pi minus 4 alpha. That will be simply sine 4 alpha. Now we know the formula for sine 3 alpha. That is simply 3 sine alpha minus 4 sine cube alpha. So sine 4 alpha can be written as 2 sine 2 alpha multiplied by cos 2 alpha. So here sine alpha is common in both the terms. So let us take that out and write it like this. And here sine 2 alpha is again 2 sine alpha cos alpha. And then cos 2 alpha will be as it is. Now, since alpha is equals to pi by 7, sine alpha is not equals to 0. It is clearly not equals to 0. And this is the reason why you can cancel out the sine alpha on both sides. Now on the left hand side you have 3 minus 4. So sine square alpha can be replaced with 1 minus cos square alpha. This is equals to 4 times cos alpha. And this cos 2 alpha can be replaced by 2 cos square alpha minus 1. Alright. So now this is simply 3 minus 4 plus 4 cos square alpha is equals to 8 cos cube alpha minus 4 cos alpha. So bring everything to one side, then you'll get 8 cos cube alpha minus 4 cos square alpha minus 4 cos alpha plus 1 is equals to 0. Now let us consider 2 cos alpha is equals to p. So then this equation will become p cube minus p square minus 2p plus 1 is equals to 0. So what is the goal of the problem? So the goal of the problem is to prove that cos alpha is irrational. So we have to prove that cos alpha is irrational. Alright. So now let us analyze this particular cubic equation. So let us say this has rational roots. So what are the possible rational roots of this particular equation? So when the coefficient of the highest degree term in a cubic polynomial is 1, then the rational roots must be the factors of this constant term. Alright. So this is what the rational root theorem says. In case if you're not aware of this, so just Google it up and you'll be able to understand. This is the basic theory. So in this case, your constant term is 1. And The only rational terms, so okay, so let us be more generic. I'll explain you the rational root theorem as well. So let us say ax cube plus bx square plus cx plus d is equals to 0 has rational roots. So then that rational root will be of the form p upon q, and p is something that divides d and q is something that divides a. Alright. So p is an integer that divides d and q is an integer that divides a. This is what rational root theorem says. Now you have 1 here and 1 here. So the only possible rational values will be minus 1 upon 1. The only possible values for p by q will be minus 1 upon 1 or 1 upon 1. So you will not be able to get any other value apart from these two values. So you can check it out. So for example, let us check. Let me explain it to you for one more cubic polynomial. So let us say you have this. So then your p by q can be, so your p can be 2 or 1. So your p should divide this. It can be 2, 1 or minus 2 or minus 1. Similarly, your q can be, q should divide this. So your q can be 1 or minus 1. So if your q is 1, you will get these. If your q is minus 1, you will get these. So this is 2, 1, minus 2, minus 1. So these values, whatever they are. So that is how you find out the rational roots of any polynomial. Alright. So in this case, the only rational roots possible are minus 1 and plus 1 if they exist. So now let us check. So this is the equation. P cube minus p square minus 2p plus 1. If rational roots exist for this equation, they must be either plus 1 or minus 1. And no other rational root is possible for this equation from rational root theorem. So if you substitute 1, it will not satisfy this equation. Even minus 1 doesn't satisfy this equation. Hence we conclude that this equation does not have rational roots. Alright. So therefore all the roots are irrational. So what is the root of this? What is p? P is equals to 2 cos alpha. This is what we have assumed. Alright. When deriving this equation, this is the substitution we made. So therefore 2 cos alpha is irrational, and hence cos alpha is also an irrational number. Hence proved. So now you understand how to prove that cos pi by 7 is an irrational number. So now what is fascinating here is that we never calculated cos pi by 7. We simply trapped it inside a polynomial and then used algebra to show that no rational number could be hiding there. This is a beautiful example of how trigonometry and algebra secretly work together. At this point, I would like to leave you with a homework problem. And this will be the next problem that is going to be discussed in the next video. So can you prove that cos 1 degrees is an irrational number? The method that we have discussed in this video will not work for this. You have to think something creative and come up with a new approach. So give it an honest try. Now, if you like the content that I'm making, subscribe the channel, share it with your friends, and do not forget to like the videos. I'll meet you in the next video with one more amazing problem. Till then, take care.